We are going to find the limit of 1 minus cosine x to the power of n times cosine nx over x squared as x approaches to 0. This problem comes from the mathematical reflections in the year 2019. I have provided a link in the description to the article. And in this video, I will be presenting two ways to find this limit. The first way is actually pretty direct, which is by using the good old L'Hopital's rule. We can use this because as x tends to 0, the numerator and the denominator tends to 0 too. So this is an indeterminate form of type 0 over 0. And we are safe to apply L'Hopital's rule here. So what L'Hopital's rule is essentially about is that the limit that we are trying to find is the same as the limit if we have differentiated each of the functions in the numerator and the denominator. So the derivative of the denominator, which is x squared, is just 2x. And to differentiate the function in the numerator, we use the product rule. And I won't go through the details of taking the derivative, but what you will end up with is this function. Then if you kind of plug in x is equal to 0 in both of the numerator and the denominator, you will see that this is still an indeterminate form of type 0 over 0. And so, we shall apply L'Hopital's rule again. And after you have gone through the differentiation, you will get this large expression over here. And luckily, the denominator is a constant now. And when x tends to 0, the first and the third term in the numerator tend to 0. And the other two terms tend to n and n squared. Therefore, we are left with n times n plus 1 over 2. And this is our answer for the limit. Now, if you have a hard time taking the derivative in the first method, then you might want to watch this second method. We need two facts. The first one is the Maclaurin series expansion for cosine x. And the second one is the binomial expansion for 1 plus x to the power of n. Now I'm going to write all the terms with powers of x greater than or equal to 4 in the series expansion of cosine x as O of x power 4, which is the big O notation to say that all the terms with powers greater than 4 has roughly the same size as x power 4, near 0. Similarly, I can write all the terms with powers of x greater than or equal to 2 in the binomial expansion as O of x squared. We can now see how useful this big O notation in simplifying our calculations. Using the first two, we can easily get cosine nx is equal to 1 minus n squared x squared over 2 plus O of x power 4, just by replacing x with nx. Then for cosine x power n, we raise the Maclaurin series expansion of it to the power of n. By treating this as a binomial, we get this expression just by replacing x with negative x squared over 2 plus O of x power 4. Then we can distribute the n, and the rest of the terms can be written compactly as O of x power 4, which prevents us from a messy expression. Now with these two expressions, we can substitute them into our limit, which after expanding, we see that most of the terms can be absorbed into just a O of x power 4. And the terms with degree less than 4 are just 1 minus n times n plus 1 over 2 x squared. Distributing the negative inside the parentheses, we see that the 1 is cancelled out, and dividing by n squared, we can split the limit into two parts, which the first part is just a constant n times n plus 1 over 2, and the second part O of x power 4 over x squared, which is O of x squared. And letting x tends to 0 will be just 0. Hence, the final answer is just n times n plus 1 over 2, which is the same answer we have previously. If you have reached here, make sure to subscribe to the channel and click the video on the screen right now to watch how I solve this trigonometric limit, and I will see you in that video.